Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today we are going to discuss about P-channel MOSFET. Let us see the overview of today's presentation. So let us start with the introduction to the MOSFET, then followed by P-channel depletion mode MOSFET, its characteristics, and P-channel enhancement MOSFET and its characteristics. So conclude with summary. So coming to the introduction to the MOSFET. So MOSFET is a 3-terminal device. It has gate, drain and source are the 3 terminals, and it has 2 PN junction semiconductor device. It's a voltage control device. FET is just like a FET, field effect transistor. MOSFET is also a voltage control device. So FET is a unipolar device depending solely on either electrons or holes. Here P channel conduction. So that means, so if the channel is P type material, so then we can say the conduction is due to holes, then we can say P channel FET. The charges present in the FET establish an electric field which controls the conduction path of the output circuit without the need of direct contact between controlling and controlled quantities. Here controlling means, so we have 3 terminals, gate, drain and source. So here gate voltage is the controlling parameter and drain current, output current ID is the controlled quantities. Okay, so let us see the MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor, and we have 2 types. Enhancement mode MOSFET. Again, enhancement mode MOSFET is subdivided into N channel and P channel MOSFET, and then depletion mode MOSFET is subdivided into N channel and P channel. So just like N channel, P channel, FET. So let us discuss in detail about the P channel depletion mode MOSFET. So this is the basic structure of P channel depletion mode MOSFET. The construction of a P channel depletion mode is exactly opposite or reverse to the N channel depletion mode MOSFET. So where in N channel N channel depletion mode MOSFET, the substrate is P type. Okay, so whereas in this case in P channel depletion mode, the substrate is N type. So this is your substrate. So if you observe, the substrate is made up of N type semiconducting material, and that can be termed as the terminal termed as this substrate SS. There is now an N type substrate and a P doped regions under drain and source connections. So you can observe here. So this is a P type region and P type region under drain terminal and source terminal. And now a silicon dioxide layer is drawn in between 2 type wells of the top on the top. So on the top side, so there are drain terminal and source terminal. Under drain terminal we have P type region and P type region on both sides, on top side. So in between these, so these are the metal contacts. In between this we have a SiO2 layer. This layer is SiO2, silicon dioxide layer, and this acts as a insulator. A metal contact is made at the top of it, and terminal is taken as gate terminal. So this is the gate terminal. The body terminal and source terminals are internally shorted and connected to the ground. So you can observe here, see the substrate terminal and source terminals are internally connected. So hence actually the output viewed as 3 terminal device, but it has the substrate and source are internally connected. So this is the basic construction of P channel depletion mode MOSFET. Let us see the operation of P channel enhancement mode MOSFET. So P channel MOSFET. So first let us see the gate to source voltage is very less. That means less than 0, negative value. So here create a channel. So how to get the channel first? So we have to create the channel. So create a channel for the free movement of holes to get the drain current. So if the once channel is created, drain current can be generated. So the gate must be at lower potential, hence free holes will move toward the gate terminal. So if the gate must be at a lower potential, that means negative value. So if the gate is at negative potential, so this is metal, okay. So these are the negative charge particles. Hence these free holes will accumulate near the gate and will not escape. So that means, see here, so initially there is no channel. So now we are creating channel. So for that, gate is at negative and this negative terminal attracts the positive charge particles. So the silicon dioxide layer will allow more free holes to accumulate near the gate terminal with less voltage applied at the gate. So with the negative voltage at the gate, so all the positive holes are attracted towards the gate, and this SiO2 layer attracts because on positive side positive charge particles and here negative charge particles. So up on top of SiO2 layer have a positive terminal because gate is negative. So gate is negative, so positive charge particles will be it will be accumulated at the on the top layer on the of the SiO2. So lower edge of the SiO2 layer is negative. So those negative charge particles will attract free holes. So on reducing VGS further, high electric field is developed, forcing atoms inside the N-type substrate to break. The free electrons generated will be electrons near the gate region. So in such a way that so we can able to generate a channel near the under SiO2 layer. So this way electrons are pushed away from the gate terminal, increasing p-type behavior near the gate terminal. So here we have p-type under gate source and drain terminals. So nearby this, so because of increasing the negative value of this gate, then those electrons are attracted by this p-type material. So this is induced p channel. Now a p channel is created between the two p wells. And now the VGS means gate to source voltage is at which the channel is created is called threshold voltage, VT. And when VGS is greater than VT, that particular threshold voltage, P channel is induced near the gate terminal as shown in the figure. So you can observe here. So this is the basic operation involved in the P channel enhancement mode MOSFET. So we have to first we have to create the channel, we have to create, and by that way we can able to generate the ID, drain current. So coming to the next operation, next case, if VGS is greater than VT and we have to apply some external voltage, that is VDS is less than 0. So but light voltage, minimum voltage we have to apply between drain to source, that is across this. This is, so by applying drain to negative terminal and this source to the positive terminal, and that too drain is positive at the positive terminal. So this is connected to negative. So that means you can observe positive is connected to negative means reverse bias. So apply a voltage source between drain and source, keeping the drain at lower potential. The drain current starts to flow. So the drain current will flow from the drain. So now on the increasing the negative value of VDS further, ID will also increases. So drain current also increases if you increase the drain to source voltage. On increasing the negative voltage at the drain terminal, reverse bias is formed at the PN junction near the drain terminal. This will result in the thick depletion region near the PN junction. So you can observe here. So this is the thick depletion region. Because we are increasing the reverse bias voltage near the drain. as reverse bias voltage increases, the thickness of the depletion region also increases. So therefore, hence, on increasing negative value of VDS further, the channel near the drain terminal becomes narrow. So the drain current will face more resistance near the drain terminal. So less current, and then a situation will occur when the drain current becomes constant and will not increase further. So it gets saturation. The situation is called pinch off situation, and the drain current is called saturation current. Increasing ID further increases the negative value of VGS. This will increase the width of the complete P channel. So hence VGS is the controlling voltage. So by changing the controlling gate to source voltage, we can able to control the output current ID. Hence it is called voltage control device. Now coming to the characteristics of this P channel enhancement mode MOSFET. So if you increase drain current, further increases the negative value of VGS. So this is the negative value of VGS. So from the threshold voltage, this is VT, threshold voltage, and from the threshold voltage, if further increase, ID also increases. So VGS, negative value of VGS. So from this, the drain current increases. So VGS controls the voltage. From this graph, it is clear that ID will become constant at a specific value of VDS. At a specific value of VDS, ID will be constant. And current ID increases only when the negative value of VGS increases. So current is only increases. So actually this is drain characteristics, and this is drain characteristics, and this is transfer characteristics. So usually drain characteristics means it is the graph drawn between output voltage VDS to the current output current drain current ID, right? Whereas transfer characteristics can be able to generate in two different ways. One is from the drain current equation, that is ID equals to IDSS into VGS 1 minus VGS by VP whole square. So this is the expression. From this we can also able to generate this transfer characteristics, and from the output characteristics. So this is the drain characteristics. So from this we can able to generate all these transfer characteristics of the MOSFET. Okay. So when negative values of VGS, gate to source voltage, increases, so obviously from a particular threshold voltage, the current increases ID. So if you further increases the drain current, so VGS also increases, and at a particular voltage, threshold voltage, it will the current drain current goes to saturation. So after that, your current will be constant. So that is about today's presentation. So we have started with the introduction to the MOSFET and what is the basics of MOSFET we have discussed, followed by P channel depletion mode MOSFET and P channel enhancement mode MOSFET, and we have discussed drain and transfer characteristics of the MOSFET, P channel MOSFET. So this is the about today's presentation. So tomorrow we'll start in the next session. We will probably special purpose diodes, that is under unit 5. Thank you.